Hi everyone, today we are going to see the next problem from the blind certified sheet, which is valid anagram. Before moving to the problem statement, we'll see what is an anagram is basically. For the people who know, it's well and good. For people who don't know what is anagram, we'll talk about a small story or small scenario by which you can understand what is an anagram is. So let's assume that you are in assume that you are in a spell bee competition. Okay, so you are in a final round. So what is the challenge in the final round is the judges will give you a word, a valid word. They will give you a valid word. You have to rearrange all the letters and make another valid word. Okay, I hope you got it. Let's see an example. Okay, so you are given a word which is listen. Okay, the judges gave you listen, listen. Pause it for a few seconds and think what other word you can make with help of these alphabets. What you can make with this is silent. So silent is also a valid word which is made up of this original word. Listen, you just shuffle the words, shuffle the letters, and you made a silent. This is what called anagram is. Now let's move on to the problem statement. I hope what is anagram has been cleared. Now, if you go to the problem statement, what they are telling us, you will be given a two word, which is yes and which is T. So you have to tell whether T is an anagram of yes. We can take this example itself. Let's assume this is a T, and this is a S and this is a T. So they will give this as input. You have to tell whether T is an anagram of yes. Okay, so we already taken this as example, so this is a valid anagram. Let's take another example. Let's take yes is going to be dog and T is going to be cat. So is there any possible arrangement that will bring cat to a dog? Is it possible? No, right? So this is not going to be a valid anagram. So you cannot make cat to a dog, right? That's not a valid anagram. If I take another example, let's take S is going to be eat and T is going to be let's keep tea, drinking tea. Okay, so is T is anagram of yes? Just think for a while. Yeah, the answer is yes, because if you just rearrange this T to this place, it will become eat, which is the original string, right? Just so simple. You just rearrange this T starting to the end. You can do rearrangement in any order. You can just shuffle it anyway. Now we just shuffle it to the letter T to the end. It become eat. So this is the valid anagram. I hope you understand what is the input and what is the required output. Output is going to be Boolean value, whether it's going to be true or it's going to be false. That's what you have to return. So first we'll see what is a brute force solution is. Okay, so brute force solution is very simple. I'll write a pseudocode. Before that we'll explain what is the process. Okay, so, and then we'll write pseudocode, and then we'll move to the optimal solution, and we'll write again pseudocode. At last we'll write the execution code in Python. Okay, pseudocode you can just apply in any language. It's just a pseudo one. You can apply to your own language. That's not a big issue. So let's take a input, the last input which we take, eat, and T is going to be T. So brute force approach is going to be, we just sort both the letter and you can just compare. So basically sorting will bring the given string into a particular order, right? Either it can be from smaller to higher or higher to smaller. You can apply sorting in string also. You can apply it to array. If you apply sorting in integer, it will make sense, but for string it doesn't make sense, right? But it will work. Okay, it will treat every single character as an ASCII. So if you see ASCII as a different value, each and every character have a different value. So it will use ASCII to sort this string basically. If you sort this one, what we'll get is A, E, T. Because if you see, even if you take in alphabet wise, A should come first and E will coming next and T will be also coming next. This is what a sorted order of a string is. If you sort this one also, you will get A, E, T. Now if you see both the strings are equal, you can directly tell that this is an anagram if the sorted version is equal. It's a simple solution. The basic idea, you just sort the given two string and you just compare whether the both are equal or not. If both are equal, then it is an anagram. If not, it's not an anagram. If I take another example, yes, it's going to be dog, and T is going to be cat. So if you sort dog, you will get D, G, O. This is the alphabetical order for a dog. And if you sort this one, you will see A, C, T. If we compare this, is this equal? No, right? This is not equal. So this is not a valid anagram. This is what a simple brute force. If I want to write a pseudocode, what I can do is function check. I am getting S and T. This is going to be sorted. Yes, you're just going to simply write sorted of yes. Again, this is just a brute force, so don't confuse with it. You have to implement in your own language how you will implement. So sorted T. And now both the thing has been sorted. Now we just return sorted S is equal to sorted T. Just simple, right? The brute force solution is very simple, just few lines of code. But if you calculate the time, this will take n log n, where n is the number of character in S. If you take this, it will take m log n. Why m? Because this can have m character, right, which is the length of word T. Okay, and then if you just add up, the total time complexity will be O of n log n plus m log n, which is pretty high. We can do some. Okay, I'll forgot about space, right? Space is going to be O of n because we are not using any kind of spaces. We can do a better solution than this. We can reduce the time complexity way much better. For that, what we can do is what we can do is we can use the HashMap data structure. I will just explain my logic and then we'll see the pseudocode. So what basically anagram is, you have to check whether the word is an anagram of another word, right? So what is the criteria to be an anagram? If you think what is a criteria, the word must have the same frequency of another word. What I mean is, if you see, again we'll take S is going to be listen and T is going to be silent. So how are you telling this is an anagram? The frequency of every character is same here also, right? The frequency of all the character, frequency in the sense the occurrence of each character. If you count, L occurs one time, right? And then I occurs one time, and S occurs one time, and T occurs one time, and E occurs one time, and N occurs one time. This is the frequency of this word. So if word need to be anagram of it must satisfy this condition. It must have the same frequency. If you make frequency for this, S occurs one time, and L occurs one time, E occurs one time, I occurs one time, and then T occurs one time. If you compare this both frequency, the both are equal. That's why you tell them as an anagram, right? This is a basic idea how to implement the optimal solution for it. Okay, if you take an invalid example, same example, we are just going to get dog and then T is going to be cat. If you write a frequency of this, D is going to occur one time, O is going occurring one time, and G is occurring one time. And if you find the frequency for this word, C is occurring one time, and A is occurring one time, and T is occurring one time. If you just compare this both, do you find any similarity between this frequency and this frequency? No. Here D occurs one time, but if you see D is not at all present here. If you see O occur one time, and O is not at all present here. Again, G present here, but G doesn't even present here. How could this be an anagram and valid anagram, right? The basic idea, just make a frequency counter and compare whether this both are equal or not. This is the basic idea of this optimal solution. Now we'll see the pseudocode. Okay, now we'll talk about the more detailed solution of it. This is a basic idea, then only you can understand the pseudocode. Again, we will have the function check, and you will be given S and T. Okay, now let's think about a base case, that whether you can make or whether you can tell this both word is anagram if one word has greater length and one word has different, I mean both have different length. Do you think it's possible to tell whether both are anagram if they both varies in size? No, right? So initially you can check that if length of S not equal to length of T, you can directly return false. You cannot make or you cannot tell the word is anagram if their length varies. That's the simple logic. Just return false. So you cannot make a valid anagram out of a vary size of length. And now we can use an HashMap. So different language of different way of using it. Now we'll write a pseudocode alone. Okay, now we have frequency counter. Frequency is going to be an HashMap. Okay, we'll declare an HashMap. Now we'll iterate every character of S and we'll update the frequency. Okay, so for character in S, this is a simple pseudocode. We will just check whether character in S. So if character is an S, we'll just increment the counter simply. So frequency of character plus, just simple. If it already exists, just increment from 1 to 2, just simple thing, right? If it doesn't exist, it's going to be seen for the first time, we'll just mark it as 1. Okay, so frequency of character is equal to 1. If it's going to be seen for the first time, we'll make a counter as 1. If it's going to be seen for next time, we'll increment from 1 to 2. Again, if we seen for the third time, it will be 3. If I want to give example, we'll take a small example, like S is going to be A, B, B, A, C. Okay, so what will be frequency for this? A, B, B, A, B. Okay, wow. So first will be here the letter A. So now A count will be 1. It will move to the B. Again B will be 1. We'll move to next letter. So B will from 1 it will increment to 2 because we seen B for 2 times, right? So this count will be 2. Again we'll move to the next. We'll see A, and A counter will be increased to 2. Again we'll move to the last letter. We found that B is seen again. Now we'll increment this counter to 3. This is what this basically does. Okay, now next step, we are just going to write an optimal code. Okay, this can be written in a different format, but this is the most optimal, I guess. Now what we have to do is, we'll go for the next page. Okay, now what you have to do is, we have to loop through the another word which is T. We have to loop through the given another word, and we have to compare that whether it's possible to make an anagram or not. That's what we discussed also, right? We'll write the code for character in T. We'll take the same example, silent, and S is going to be listen. Our HashMap will look like, copy this here, we'll just keep it aside, and now our pointer will be at yes. Okay, now we'll check if frequency of character is greater than 1. Okay, if it's greater than or equal to 1, if you see here, it's greater than or equal to 1. So what we can do is we can just decrement the counter, character minus, just decrement it. Okay, so now if you decrement, this will become 0, right? I will tell the reason why we are decrementing it. Okay, so another case will be like if the frequency, or you can directly put else, right? You can directly put else. This will fail when it is less than 1. Okay, this condition will fail when it get less than 1. So if it get less than 1, we can directly return false. You can ask me why I should return false. For that, we'll take the small example, silent, right? SLIENT. We'll add one more s. Okay, so if you just iterate to all this thing, you will cut out s and you will cut out LIENT. All this count will become 0, right? All this will become 0. Now when you move to s, if you check this condition, if you check this one condition, this will get failed because the frequency of s is 0. Okay, you cannot make an anagram without the frequency of this word. The frequency of s is 1 in the original, but in the given word it is 2. So you cannot obviously make the anagram out of it or valid anagram out of it. So you can directly return false over here if the frequency get decreased. Okay, this is the most optimal one. Okay, that's why it might be a bit confusing, but if you see carefully, it will make sense a lot. So what could be another case? Okay, so what could be another case is we seen an example where s is going to be dog and t is going to be cat. So how do you handle this scenario? Okay, this frequency will be d is going to be 1, o is going to be 1, and g is going to be 1. So when we running through this loop, it doesn't make any changes, right? Because this character is not at all present. I mean, any of this character is not at all present in this, so it doesn't make any changes. So what we can do is we can write one more if case, that if the character is not in frequency. Okay, basically if it's not in a frequency, you cannot even make an anagram. You can directly return false. Just simple. Okay, so you will just check whether C is in this HashMap or not. No, it's not there. Obviously, if something doesn't exist in the original array, you cannot make an anagram. So you can directly return false over here. And then at last, you can directly return true. At last, you just return true. This is the optimal code for it. I might sound a bit confusing, but we can write a code and you will understand way much better. Okay, I just forgot about time complexity, right? If we talk about time complexity, this time and space, we'll talk about both time and space. This iteration takes O of n time because you are iterating every character one time. So this is going to take O of n, and again you are iterating the second letter O of m. So if you just add both of them, it will be overall time complexity will be O of n plus m. And if you see the space complexity, we are using HashMap, which can be maximum size of 26 because alphabets are 26, right? So you can have at most 26 different keys in an HashMap, from starting from A up to the Z. At max you can have 26 character only in this HashMap. So this is going to be O of 26, or approximately O of n, we can tell. Okay, this is what the time and space. If you compare this with the previous solution, it's way much better. It's way much better compared to n log n plus m log n. O of m plus n is way much better. And if you see, we increase slightly our space. As I said in my first video, we have to sacrifice something in order to get a best thing. So we just sacrifice the constant space to O of 26, and we obviously reduce the space. This is what I mean in the first video. We have to sacrifice something to get a better out of it. We sacrifice space, now we got a better time complexity. This is what the entire optimal solution is. Now we'll code it up. Okay, now we'll see the solution in Python. I'm comfortable with that. As we discussed in the optimal solution, first we'll declare the frequency map to keep track of the frequency of letter S. Okay, and then we'll just loop over the word for character in S, and we'll just check if character in frequency map. So if it's already exists, what I said, we'll just increment the counter. Frequency map of character plus equal to 1. If it's not there, we'll just set the default value as 1. This is what we discussed, right? This is the first set, which will take a time of O of n. Now we'll look through the second list for character in T, and we talked about the base case, right? If character doesn't found in the frequency map, we can directly return false, because you cannot make a valid anagram out of something which doesn't exist on the original string. And if we talk about second base case, if frequency of character is greater than or equal to 1, you can just decrement it, right? Frequency map dot character minus equal to 1. Okay, sorry for the typo, I just forgot map. This is what the second base case. If this condition fails, we can also directly return false out of it. Again, at last we'll return false. Do you remember we talked about the base case which we discussed at the beginning, which is if length of S is not equal to length of T, return false out of it, because you cannot make anagram with a different size, right? And this, again, this time complexity is going to be O of n, and this is going to be take O of n space. Technically it is O of 26, but we just keep it as O of n. Now we'll submit this code. First we'll give a run. Oh, sorry, we have to return true, right? Yeah, I just did something wrong. Okay, now if you run this code, it will just get passed. Yeah, it's success. Now we'll submit it. Yeah, it passed all the test cases for all 52 test cases. And thanks for watching till this, and make sure to subscribe the channel so you will get the video daily. And tomorrow we'll see one problem from the blind solver series. Until then, bye.